Welcome to the next lecture that is on canonical and standard forms of the Boolean functions. So here we have some definitions. So first of all, literal. What is a literal? A variable or its components. Means when we use a variable in the Boolean algebra or Boolean function, so that variable is called the literal. Next one is product term. So product term, it means that if we use the literals by connected by the this sign multiplication, so that is are the product terms, and the sum terms if our literals are connected by the addition, so these are called the sum terms. Next come to the mean term. So what is the mean term? Actually a product term in which all the variables appear exactly once, either complemented or uncomplemented. So these terms are called the mean terms. Like suppose we have a variable x, so and we use x, x dash or xy, xy dash. So like that. These are called the mean term that was in product term. Now the max terms are in the sum terms in which all the variables appear exactly once, either complemented or uncomplemented. Means suppose we use x plus y or x dash plus y dash like that. So these are called the max terms. Now, what are the mean terms? Because here we have a lot of use of mean terms. So first of all, what is the mean term? That exactly one combination in our the truth table. And here we denote it by small mj, where j is the decimal equivalent of the mean terms corresponding binary combination bj. What is this binary combinations? You know that the binary numbers are 0 and 1 only. So bj, we have the values of 0 and 1 if we have the two variables, so we take 1 and 0. If we have the three variables, so we take 0, 0, 0 or 0, 0, 1 like that in our the truth table. So here we take the small mj mean terms, so that represents are the mean term. Now a variable in mj is complemented if its value in bj is 0, otherwise is uncomplemented. Means we take if our bj combination is 0, so we use the complemented. Means suppose we have variable x, so we use the x dash for the 0, otherwise for the 1 we use the x. Now let's take an example for this. If we have suppose three variables, so that are a b c, it means that our j is 3. So and our bj, suppose we say that in three variable our bj is like 0, 1, 1. So how can we represent this 0, 1, 1? So it's what is the mean term of this? So we can represent this mean term by 0. 0 we represent it by a dash and 1 b and 1 c. So it is mj's are a dash b c, because this is in product term, because we use the mean term and mean term is the product terms, right? Now next is the max term. What are the max terms? Actually this is the exactly one combination is also in the truth table, and we denote it by capital MG. And here the max terms corresponding to binary combinations of Bj, where capital MJ is complemented if its values of Bj is 1, otherwise uncomplemented. Means if our Bj is 1, suppose last time we take 0, 1, 1. So for 0 we take the complemented, means x dash, and for 1 we use only the x. So like an example here, if we have the three variables a, b, c, and we are bj is 0, 1, 1. So what will be the max term of this? Means how can we denote it by the max term? So for 0 we use the complemented. So that is, sorry, 0 there is a no complemented, uncomplemented, and for 1 we use the complemented variable. So it become a plus b dash plus c dash. So 0, 1, 1 in max term we represent it by a plus b dash plus c dash. We use the sum term, right? Because we calculate the max term, right? Now clear what is the mean term and what are the max term? Mean terms in the product and max term in use the sum. Now truth table notation for mean terms and max terms. Actually to denote the mean term and max term, that easy way is truth table. So in the truth table here we take the three variables x, y, z. So our truth table is like that. If we have the three variables, so we know that we have the 8 combinations of the three variables here: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So like that we have the 8 combinations here. Now, how to write the mean terms and max terms of these variables? So I told you that in the terms of mean terms, we represent the 0 by the complemented variable. So here the mean term is x dash, y dash and z dash, or in the product. So x dash, y dash, z dash, and we represent it by small m0. So we start with 0. So m0 this is. Now m1 is, this is x dash, y dash into z. M2 is x dash, y, z dash, this is our M2. X dash, y, z, this is our M3. 1, 0, 0, it means x, y dash, z dash, that is our represent M4. X, y dash, z, M5. X, y, z dash, M6. X, y, z. So this is our M7. So these are the mean terms. In terms of the max term, how can we write the max term? So max term we represent it by the capital M. So now if we have the BJR 000, it means that I told you that we represent the, if we have the BJ is 1, so we represent it by complemented, otherwise not. So here we have the 000, so we represent it by x, y, z, and this is the max term, so we use the addition terms, means x plus y plus z is equal to, this is our capital M0. And here x plus y plus z dash, our capital M1. X plus y dash plus z, this is our M2. X plus y dash plus z dash, this is our M3. X dash plus y plus z, this is our M4. X dash plus y plus z dash, this is our M5. X dash plus y dash plus z, this is our M6. And x dash plus y dash plus z dash, this is our M7. So like that we have the mean terms and the max terms. So but in this truth table of to find the mean terms and max terms, you have to maintain the order. Order here is fixed, means you write first is 0, 0, 0, not is like that you write any combination first you write, means 0, 0, 1 or 1, 1, 1. No, this order you have to maintain to find the mean terms and the max terms. So first one is 0, 0, 0, 0, 0, 1, like that. So you have to remember this order to find the mean terms and the max terms. Now, canonical forms. So what is the canonical forms? Actually, this is the unique form, that is the canonical form. So in Boolean function can be expressed as a unique sum of mean terms and a unique product of max terms. So unique means sum of mean terms, we have a unique, and product of max terms is also unique. So that is the canonical forms, called the canonical forms. So here every function has two canonical forms. First one is canonical sum of product or SOP, and canonical product of sums POS. Now, first of all, canonical sum of products, what is this? Here, the mean terms included are those mj such that f is equal to 1. Means in the truth table, we have to see that what is our resultant. If our resultant is 1, so we calculate from there are the mean terms in corresponding to the rows j, right? And it is also called the disjunctive normal form, DNF, sum of product. So canonical sum of products also called the disjunctive normal form, DNF. Now next one is canonical product of sums. So here the max terms included all are those capital Mj such that f is equal to 0, means if our resultant is 0, so in that case we calculate or we measure are the max terms corresponding to that row j. Now, and it is also called the conjunctive normal form, means the canonical product of sums is also called the conjunctive normal form, CNF. So CNF means POS and DNF means sum, SOP. Clear? Now let's take some examples for this. So here we have the truth table. If we use the three variables A, B, C and our resultant is like that. So how to find the mean terms and max terms here? So the DNF is canonical sum of products. So here in this truth table, what is the canonical sum of products or DNF? Canonical sum of products means sum of products. So sum of products mean we use the sum of mean terms. So our mean terms here, what is if our resultant is 1? So here our 1 is here. So that is our mean terms M1. This is M0, M1, M2, M4, M6. Right? Now what is our M1 here? M1 is variables are our mean terms are A dash, B dash, C. So this is our M1. M2 is A dash, B, C dash. This is our M2. Now M4 is A, B dash, C dash and M6 is A, B, C dash. So these are the mean terms. So now the canonical product of sums, if we want to find the POS or CNF. So what is the POF? Here we have to see the zero resultant. So zero resultant of this one. So we use the max term, these variables. So that is A plus B plus C. That is our capital M0 and M3. So our next zero is here. That is M3. So here this is A plus B dash plus C dash and M5. That is A dash plus B plus C and M7. So that is A dash plus B dash plus C dash. So like that we write out the CNF form from the truth table and DNF. So here you observe one thing is that our small mj is the complement of the capital MJ. It means that if we have the M1, M2, M4, M6 in our DNF, so 0, 3, 5, 7 means the remaining terms that are in our the POS. If we have the POS, so remaining terms that is are in the SOP form. So canonical product, sum of product is the complement of the POS terms, right? Now shorthand summation and product sum. So if we have the variables a, b, c, the function we denote it by summation of small m 1, 2, 4, 6. Suppose we have the mean terms are m1, m2, m4, m6, where this indicates that this is a sum of product form, and small m, this is indicates the mean terms. Now the product denoted by this sign is the product of the capital M0357, and this is capital M0357 is the max terms, that is represents the M0, M3, M5 and M7. Now let's take some examples. Suppose we know that our MJ, small mj is the complement of capital MJ. So we write that small summation of small m1246, this is equivalent to product of capital M0357. This is our F1 ABC, we can say that. Means here we include, if in our mean term we include 1, 2, 4, 7. So here we have the remaining terms, that is 0, 3, 5, 7. It will be in our the max terms. Clear? Now conversion between canonical forms. So how means SOP to POS and POS to SOP, means DNF to CNF and CNF to DNF. How can we convert it? So here we replace our summation with product and the vice versa, and replace those J's that appeared in the original form with those that do not. So here let's take some example. If we have suppose this F1, A, B, C variables are here or literals are here, and this function is represent the a dash b dash c plus a dash b c dash plus a b dash c dash plus a b c dash. Now what is this form? You can see this is the sum of product terms, means sum of mean terms, right? Mean terms, it means sum of mean terms, means this is a sum of product, this is a DNFR. So now we have to convert into the CNF, means sum of product form. So now we can write this. This is a mean term, so we can write this m1, m2, m4, m6. How? So we can use here the table. Here we have the three variables. Like that combinations we have, you have to remember this order actually to find the mean terms and max terms. Now our mean terms, here we have a dash b dash c. So where is this a dash b dash c? A dash b dash c. So this is our the m1. A dash b c dash, which will be a dash b c dash? This is a dash b c dash. So this is our m2. Now a b dash c dash, a b dash c dash, this is m4, and a b c dash, this is our m6, right? Now we need to convert this into the CNF, means sum of product form. So now in the summation form we can write this summation of 1 2 4 6, right? After that this will be equal to what? Product of what is remaining here? 0, 3, 5 and 7. So that will be comes in product terms, and in the product terms means this is the represents the product of sum terms, right? So now what is 0, 3, 5, 7? 0 means M0, capital M0. Capital M0 is this one. This represents A plus B plus C. Now M3. So what is M3? That is A plus B dash plus C dash. This is our M3. M5, A dash plus B plus C dash. This is our M5. And A dash plus B dash plus C dash. This is our M7. So like that our terms are here a plus b plus c, like that all these terms m0, m3, m5, m7. And now we can see that this is the form of SOP, sum of POS, product of sums, means CNF, right? So like that we can convert our POS to COS, our SOP to POS by the truth table. Now next we have to this function and need to find the conjunctive normal form. You can see if we have this function and this is a, what is this? This is a sum of product form. Sum of product form means this is a disjunctive normal form. So sum of product form, and here we use the two variables. So we make the two variable table, and here our order is 0 0 0 1 1 0 1 1, right? So now first one is x y dash. So what is x y dash represented? Our m2, because this is m0, m1, m2, m3. X y dash is our m2. X dash y, this is our m1, and x dash y dash, this is our m0. So now in terms of m0, m2, m1, m0, we can write it in the summation form 0, 1, 2. And in the product form, what one is left here? Only the m3. It means that in product form only left 3. And this is our capital M3. And what is capital M3 is here? X dash plus Y dash. Product of sums. So this is X dash plus Y dash. This is our required CNF. Right? Next one is, again we have another example. If we have this one and we need to convert this into the disjunctive normal form. So you can see here this is the three variable function here, and this is a product of sum form. It means CNF is given and we need to find the DNF of this. So I already told you how to make the table. So you use that three table variable, and you can see that in terms of max term, this represents our capital M5, this represents capital M4, and this represents capital M2. So in product form, we can write this 2, 4, 5. And when we convert this into the summation form, so what will be in the summation form? That what all elements are not here? 0, 1, 3, 6 and 7. So that will be included in our the summation form. Now next one, what is this? Small m0. Now in summation we have the small m0. So what is small m0 represents in three variable? That is x dash y dash z dash plus small m1 x dash y dash z, small m3 x dash y z, small m6 x y z dash, and small m7, that is x y z. So now this is our the required DNF. Now the standard forms. What are the standard forms? Till now we studied about the canonical forms. So now the standard forms, these are not the unique. And what are these? actually standard forms like canonical forms, except that not all variables need appear in the individual products, SOP or POS terms. Means here we have some variables are not included in each terms. Like example, if we have this function f1, the variables are a, b, c. If we write this a dash b dash c plus b c dash plus a c dash, so you can see that this is the sum of product form, right? But here in the second term we have not the a, and in the third term we have not the b. Means not all variables in each term. So this form is called the standard sum of product form. Similarly, if we write is like that a plus b plus c, b dash plus c dash, a dash plus c, which type of form is this? This is our POS, means product of sum. But here in the second term we have not the a term, a variable, and in the third term we have not the b. It means that this is the standard product of sum form. Clear? What is the standard form? What is the difference between the standard form and the canonical form? Now, we see here the conversion of SOP, means sum of product form, from standard to canonical. If we have given the standard form, so how can we convert this into the canonical form? So for this, we have to expand non-canonical terms by inserting equivalent of 1 in each missing term x. X plus x dash is equal to 1. We have to use this. Means in that term we have not the variable here, so we have to add that variable by x plus x dash. We have to multiply that variable with 1, so that we can write x plus x dash, that variable we have. So like an example you can see, and after that when you include there x plus x dash, so after simplification you have to remove all duplicate mean terms, then you will get your final canonical form. So if we have this three variable function here, this is our this function. Now you see here we have not a, here we have not b. So what we do here to convert into the canonical form, this is our standard form, we have to here use this a plus a dash, because our a plus a dash is equal to 1, and here we have to multiply by b plus b dash, because b plus b dash is 1. Now after that you use here the which rule? You can use here the distributive law. When you use here the distributive law, so it become a b c dash plus a dash b c dash, and again you use here distributive law a b c dash plus a b dash c. After that you see here a dash b dash c and a b c d dash and a b c dash, these are the equal terms, right? So in the second step we told you that you have to remove duplicate mean terms. So duplicate mean terms means you can use only these two terms, only the one term. Means we can write this a b c dash, a dash b dash c, a dash b c, and this is our a b dash c dash, and this is a dash b c dash, sorry actually this one. Okay, so now this is the standard canonical sum of product forms, right? Like that you have to convert your standard form to canonical form. Clear? Next, another one, if we want to find convert the POS from standard to canonical form, so here you have to expand your non-canonical terms by adding 0, because here we found the POS, so you have to add 0, because that 0 is we can write this x dash 0 is equal to 0, and again we use the distributive law. After that remove or duplicate max terms, then we find the canonical form. Suppose we have this one. Now what we do here? Here we have not a, so we introduce here, add here a plus a dash, and here we add b plus b dash. Now we use here the distributive law, then it become a plus b dash plus c dash, multiply a dash plus b dash plus c dash, and here when we apply the distributive law, so it become a dash plus b plus c dash and a dash plus b dash plus c dash. Now you can see these two terms are duplicate here, so we remove one term and remaining only the one term. So that is a plus b plus c, a plus b dash c dash, and this is a dash plus b dash plus c dash, and this one a dash plus b plus c dash. So now it converts into the canonical POS form, right? Next one is, here we have suppose this type of function. This is any Boolean function. Now we have to convert this into the disjunctive normal form. Means we have to find the disjunctive normal form of this function. So here first you see here what law we can use here. You know that here we have the complement, and for the complement we use only the De Morgan's law. So first you use here the De Morgan's law. According to the De Morgan's law, it becomes y complement complement plus z complement. After that, y complement complement, this become y by the involution law. After that, you use here the distributive law, that is xy plus xz dash. Now, after that, now this is in your standard form. Now you have to find the disjunctive normal form. And what is the disjunctive normal form actually? This is disjunctive normal form means the canonical sum of product. Disjunctive normal form means canonical sum of product. So you need to find the canonical sum of product. So for this we need here the z term, here we need the y term. So what we do here? We multiply here with z plus z dash, and here we multiply with y plus y dash because these are equal to 1. Now use the distributive law here. So this become xyz dash plus xyz dash plus xz dash y dash. After that, you can use the commutative law and write in that form of xyz dash. And here you see that xyz dash and xyz dash both are same. Means we remove here the one mean term. So it become only xyz plus xyz dash plus xy dash z dash. So this is our the disjunctive normal form, or you can say that canonical sum of product forms. Clear? Next, another example, if you have suppose this type of function is given and need to find the conjunctive normal form. So again we have the complement here. So we use first the De Morgan's law, and by the De Morgan's law it become x y dash y complement whole complement multiply x z complement. Again we have the complement of the variables. So we use again the De Morgan's law, and it become x complement plus y complement complement x complement plus z complement plus z. Now complement. Now this become y by the involution law. After that we use here the distributive law with z, x dash plus y plus z dash and x dash plus z dash plus z dash. After that z dash plus z dash, this is our the z dash by the idempotent law, a plus a is equal to a. And here, because here we have not the y term, so we include here y dash, that is equal to 0. So we add y dash to convert into the CNF. CNF is our the canonical product of sum form. Now after that we use the distributive law here. So it become x dash plus z dash plus y and x dash z dash plus y dash. After that we can write here by the this is are the conjunctive normal form x dash y z dash and x dash plus z dash plus y and x dash plus y dash plus z dash. So now this converts into our the CNF. Clear how to find the CNF to the Boolean, any Boolean function or DNF, right? Now, one important example actually here, one important you can say the theorem you have to prove here, that prove that the complete disjunctive normal form and complete conjunctive normal form is three variable. In three variable, we talk about the three variable here. In a Boolean algebra is equal to the unit and zero element of the Boolean algebra. What does it mean? It means that complete disjunctive normal form is equal to the unit means 1, and the complete conjunctive normal form is equal to the zero element is equal to 0. So how can you prove this? First of all, what is the complete disjunctive normal form in xyz? Because here we take the three variables. So what is the meaning of complete disjunctive normal form? Complete disjunctive normal form, it means that you have to take all terms. How many terms you have? 8. Total 8 terms of three variables. So you have to write all 8 terms. That is the complete disjunctive normal form. So disjunctive normal form means that the addition sum of products. So all 8 terms we have to write here. x dash y dash z plus x dash y dash z, all 8 terms we write here. After that, what we have to prove? We have to prove that this is equal to 1. So now we see that first 4 terms we have the x dash and last 4 terms we have the x are common. So now first 4 terms we take the x dash is common and last 4 terms we have the x we take common. By the distributive law we can use here. Now again we use the distributive law and we can write x dash plus x, and this is our y dash z dash plus y dash z plus yz dash plus yz. After that, what is x dash plus x? This is equal to 1 by the complement law. After that, first for 2 terms we have the y dash is common. Last 2 terms we have the y is common by the distributive law. Again we use here the distributive law, that is y dash plus y and z dash plus z. Now what is y dash plus y? This is 1. Z dash plus z, this is 1 by the complement law, and 1 into 1 we can write it 1 by which law? By the idempotent law. So now we can see here this is the unit element of the Boolean algebra, means all complete disjunctive normal form is equal to 1 always. Now we take the complete conjunctive normal form. So what is the complete conjunctive normal form? We have to write the all mean terms of the 8 one, that is this one. All 8 terms you have to write here. So means you have to write the max terms, sorry, you have to write the max terms, all max terms here. So now you need to find this is equal to 0. So what you do here? You can do here, you can see you have the first 2 terms z z dash, here z z dash, z z dash, z z dash. Always when we use the max term, so we use like y dash is equal to 0, z z dash equal to 0, right? So here we use the distributive law and we can write first 2 terms x plus y plus z into z dash. We can write this if we use the distributive law first 2 terms. When we use the distributive law next 2 terms, so it becomes x plus y dash plus z into z dash. Now like that we use the distributive law. Now we know that z into z dash is equal to 0 by the complement law. After that we have this is the identity because a plus 0 is equal to a. So x plus y plus 0 is equal to x plus y. Now after that we see that first 2 terms we have the y dash, so we can write x plus y into y dash, and these 2 terms we can represent it by x dash plus y into y dash by the distributive law. Again y into y dash is equal to 0 by the complement law, and a plus 0 is equal to our a by the a plus 0 is equal to a, means x plus 0 is equal to x, and x dash plus 0 is equal to x dash by the which identity law, and x into x dash this is equal to 0 by the complement law. So we can see here this is the 0 element of the Boolean algebra, means our complete conjunctive normal form, this is equal to 0 for 3 variables, and this is always true. I hope that now you all of you are understand how to find the POS, SOP, all these. So today's lecture is completed now. Thank you.